Welcome to this tutorial on the PySpark SQL regex_replace function. In this video, we'll explore how you can use regular expressions to efficiently search for and replace specific patterns within your string data. Whether you're cleaning up text, standardizing formats, or handling special characters, the regex_replace function is a powerful tool that will help you manage unstructured or messy data with ease. Let's dive in and see how this function can make your data transformation tasks much simpler. Introduction to the regex_replace function. The regex_replace function in PySpark is a powerful tool for manipulating and cleaning string data using regular expressions regex. This function allows you to search for specific patterns within a string column and replace them with another substring. It works by applying a regex pattern to the column, identifying matching parts of the strings, and replacing those portions with a new value. This is particularly useful when dealing with text data that contains unwanted patterns such as special characters, extra spaces, or specific terms that need to be cleaned or standardized. For example, if your data contains strings with inconsistent formatting like phone numbers with various separators e.g. dashes, spaces, or dots, you can use regex_replace to find all occurrences of those separators and replace them with a uniform symbol, such as a dash. The function is also handy for replacing special characters, removing certain words or phrases, or standardizing data formats across a dataset. By leveraging regular expressions, regex_replace gives you the flexibility to define complex patterns, making it a go-to function when working with unstructured or semi-structured text data that requires transformation or cleanup. Whether you're preparing data for analysis, ensuring consistent formatting, or removing unwanted elements, the regex_replace function is a reliable method for handling pattern-based replacements in PySpark. Basic syntax. The regex_replace function in PySpark allows you to modify string values in a data frame by searching for specific patterns and replacing them with new substrings. The basic syntax involves importing regex_replace from pyspark.sql.functions and then applying it to a data frame using the select method. The function takes three key parameters: the column containing the string data to modify the regex pattern you want to search for, and the replacement string that will replace any matches found by the pattern. In the syntax, dataframe.select regex_replace column pattern replacement.alias new underscore column. The column refers to the column in the data frame that holds the string values you want to manipulate. The pattern is the regular expression that defines what you are trying to find in the string. Regular expressions regex give you powerful flexibility to search for various patterns like specific characters, numbers, special symbols, or even entire words. The replacement is the string that will replace the part of the column values that matches the pattern. This basic syntax provides a straightforward way to clean and transform string data by leveraging the power of regular expressions, making regex_replace an essential tool for handling unstructured or inconsistent text data in PySpark. Why use regex_replace function? The regex_replace function is an essential tool for cleaning and transforming string data, especially when you need to identify and modify specific patterns within a column. This function is particularly valuable when dealing with unstructured or messy data that contains inconsistencies like special characters, unwanted symbols, or improper formatting. For example, if you're working with a dataset where text inputs may have varying formats such as dates or phone numbers, or where certain characters need to be standardized or removed, regex_replace provides an efficient solution. One of the biggest advantages of using regex_replace is the ability to leverage regular expressions, which allow you to define complex patterns that can match multiple variations of a string. This flexibility means that rather than searching for exact matches, you can use a single regex pattern to find and replace multiple variations at once. For instance, you can use it to strip out unwanted characters like punctuation marks, replace inconsistent delimiters, or even correct common misspellings in a text column. This makes replace a powerful function for a wide range of tasks, from data cleaning to text transformation. It ensures that your string data is consistent and ready for further processing or analysis, saving time and reducing the risk of errors that could arise from inconsistencies in the data. Whether you're preparing data for machine learning models, creating reports, or simply ensuring accurate data entry, regex_replace helps you clean and standardize your text data with precision and efficiency. Practical examples: 1. Replacing all occurrences of a substring. In this example, we are using the regex_replace function in PySpark to clean up a product_code column that contains values with dashes. The data frame df contains product code such as a BC123 XAZ, def456 UVW, and G789 RST, where dashes separate different parts of the product code. The goal is to replace these dashes with spaces, making the product codes easier to read and more consistent for further processing. To achieve this, we apply the regex_replace function to the product_code column. This function takes three arguments: the column to modify df.product_code, the pattern to search for, in this case, the dash symbol, and the replacement string, a single space. The function scans each value in the column for dashes and replaces them with spaces, effectively transforming the product code format. We use the select method to apply this transformation and create a new column which is renamed to cleaned_product_code using the alias function. When we display the result using the show method, we see that each product code has been updated. Dashes are replaced by spaces. So BC123CZ becomes a BC123XIZ. Def456UVW becomes Def456UVW, and G789RST becomes G789RST. This example demonstrates how regex_replace can be used to clean and transform string data in a structured way. By replacing specific characters like dashes with spaces, you can standardize your data and make it more readable, which is especially helpful when preparing data for reporting, analysis, or further transformations. The flexibility of regular expressions allows you to target specific patterns in your data and replace them efficiently, making this function a valuable tool for data cleaning in PySpark. 2. Removing special characters. In this example, we are using the regex_replace function in PySpark to clean a column by removing all non-alphanumeric characters from the string data. The data frame df_special contains a column called text with values like product at 123, price $50 per cent, and code ABC, where each string includes special characters such as at, dollar, per cent, and that we want to eliminate. The goal is to retain only alphanumeric characters, letters, and numbers, and remove any other characters that are not part of the alphabet or digits. To achieve this, we apply the regex_replace function to the text column. The regular expression pattern ESRZ09 is used to define what we want to remove. In this case, the syntax means match any character that is not inside the bracket, so it matches any non-alphanumeric characters. The pattern looks for anything that is not a letter, a Z or a Z or a digit 0 to 9, and replaces those characters with an empty string, effectively removing them. We apply this transformation using the select method, and the resulting clean strings are placed into a new column named cleaned underscore text using the alias function. When we display the result using the show method, the special characters have been successfully removed, leaving only the alphanumeric characters. For example, product at 123 becomes product 123, price $50 per cent becomes price 50, and code ABC becomes code apps. This example highlights how regex underscore replace can be used to efficiently clean string data by removing unwanted characters, such as special symbols, and retaining only the desired alphanumeric content. This is particularly useful when preparing data for analysis, reporting, or input validation, ensuring that your text data is clean, standardized, and ready for further processing. 3. Replacing patterns in date strings. In this example, we are using the regex underscore replace function in PySpark to standardize the date format by replacing different separators such as slashes and dashes with dots. The data frame df underscore dates contains a column called date with various date formats including 2023 10 12, 2023 1012, and 2023 0101, where the dates are separated by slashes or dashes. To create a consistent date format, we want to replace all instances of slashes and dashes with dots. The regex underscore replace function allows us to achieve this by searching for the patterns we want to replace and substituting them with the desired character. In this case, the regular expression is used to match both dashes and slashes. The brackets indicate that any character inside the bracket should be matched, so this pattern looks for either or in the date column. We apply the regex underscore replace function to the date column, replacing any occurrences of or with a dot, resulting in a standardized date format. Using the select method, we create a new column named standardized underscore date by renaming the transform result with the alias function. When we display the result using the show method, we can see that all the dates now follow the same format with dots separating the year, month, and day. For example, 2023 10 12 and 2023 1012 are both transformed into 2023.10.12, and 2023 0101 becomes 2023.01.01. This example demonstrates how regex underscore replace can be used to standardize date formats in a data frame by replacing different separators with a consistent character. This is especially useful when working with datasets that may contain inconsistencies in how dates are formatted, ensuring that your data is uniform and ready for further processing or analysis. 4. Replacing multiple patterns in one step. In this example, we are using the regex underscore replace function in PySpark to clean up text data by replacing both commas and semicolons with spaces. The data frame df underscore text contains a single column named text with values such as hello, world, hi there, and goodbye everyone. Each of these strings contains commas and semicolons that we want to replace with spaces to create cleaner and more consistent text. The regex underscore replace function allows us to search for multiple patterns in the text column and replace them with a new value. In this case, we use the regular expression pattern to match both commas and semicolons. The square brackets define a set of characters to search for, and the pattern matches either a comma or a semicolon. We then replace these matched characters with a single space, ensuring that the punctuation is removed and replaced with consistency. The transformation is applied using the select method, and the result is renamed to cleaned underscore text using the alias function. When we display the clean text using the show method, we see that the commas and semicolons have been replaced by spaces. For example, hello world is transformed into hello world, hi there becomes hi there, and goodbye everyone becomes goodbye everyone. This example highlights how the regex underscore replace function can be used to clean up and standardize text by replacing unwanted characters such as punctuation with spaces. This is particularly useful when working with datasets where text needs to be prepared for further analysis or display, ensuring that the data is free from unnecessary punctuation while maintaining readable formatting. 5. Using regex underscore replace with complex regex. In this example, we are using the regex underscore replace function in PySpark to replace all numeric values in a column with the word number. The data frame df underscore numbers contains a column name description with entries such as item 123, product 456, and order 789, where each string contains a numeric value that we want to replace. The regex underscore replace function is applied to the description column, and we use the regular expression pattern D to identify numeric values. The D pattern matches any digit, and the symbol means one or more digits. This combination allows us to search for all sequences of numbers within each string, no matter their length. Once the numeric values are identified, they are replaced with the word number. The transformation is performed using the select method, and we rename the resulting column to cleaned underscore description using the alias function. When we display the result using the show method, we see that the numeric values have been replaced as intended. For example, item 123 becomes item number, product 456 becomes product number, and order 789 is transformed into order number. This example demonstrates the flexibility of the regex underscore replace function in PySpark, allowing you to replace numeric patterns in text data with a specified string. This technique is especially useful in scenarios where you need to mask or standardize numerical data such as product codes, order numbers, or other sensitive numeric information while maintaining the readability of the surrounding text. 6. Handling null values with regex underscore replace. In this example, we are working with a data frame that contains both string values and null values, and we want to replace dashes with spaces while handling the null values safely. The data frame df underscore with underscore nulls contains a column name product underscore code with values like abc123, a non-null value, and XYZ 789. Our goal is to replace the dashes in the string values with spaces, but we need to ensure that the null values are handled properly without causing errors or unwanted transformations. The regex underscore replace function is used to search for dashes in the product underscore code column and replace them with spaces. The pattern identifies the dashes in each string, and the replacement value is a space. However, when working with null values, it's important to note that PySpark functions like regex underscore replace handle nulls safely by leaving them unchanged. This ensures that null values remain none and are not affected by the transformation. Using the select method, we apply regex underscore replace to the product underscore code column and create a new column named cleaned underscore product underscore code using the alias function to represent the transformed data. When we display the results using the show method, we can see that the dashes in the strings have been replaced by spaces while the null value remains untouched. For example, ABC123 becomes ABC123, says 789 becomes excised 789, and the none value stays as none. This approach demonstrates how to handle null values gracefully while performing string transformations using the regex underscore replace function. By ensuring that null values are preserved, we can safely clean and standardize the string data without introducing errors or altering missing data, making this technique useful in data cleaning workflows where null values may be present. That's it for today's tutorial on the PySpark regex underscore replace function. As you've seen, regular expressions give you the flexibility to find and replace patterns in your data, making it cleaner and more consistent. Whether you're dealing with special characters, numbers, or formatting issues, This function is a great way to standardize and clean up your strings. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more PySpark tutorials. Thanks for watching and see you in the next video.